All right, so we're going to continue our discussion on mass percent. What we did before was a qualitative look. So qualitative basically means no numbers, right? Something is saturated or unsaturated, something like that. What we're going to take a look at now is the quantitative. So many T's. Quantitative version of this, right? So in this case, we're going to include numbers, right? So instead of just saying, hey, we dissolve this into this to make an unsaturated solution, we want to know exactly how much solute is in our solvent. And so obviously the quantitative side is going to take a much more mathematical approach, which students generally tend to struggle more on. But again, you really just want to get some practice in there to solve it. So the first thing we want to take a look at is mass percent. So mass percent is equal to the mass of the solute over top of the total mass, right? So the total mass would be the mass of the solute, or maybe even more than one solute, plus the mass of the solvent. And since it's a percentage, we take it times 100%. So we can use mass percent in a bunch of different ways. So for example, if you have a 12% NaCl by mass solution, how many grams of NaCl do you have in 235 grams of solution? Right, so we obviously have some kind of solution that has NaCl in it. It's 12% by NaCl by mass, and we want to know how much we have in our how many grams of NaCl we have in our solution. So these are unit conversion type of problems. So generally unit conversion problems, you want to start with a thing that is not a conversion unit. So the thing is not some unit over some other unit. So mass percent is a unit over a unit, right? It's a mass of solute over a total mass. So that's a conversion. We don't want to start there. And then we have 235 grams of solution, right? That is just a number by itself. That's not a conversion unit. So that's generally where you want to start. So we have 235 grams of solution. And then we want to think about this 12% NaCl and how we can write that out. So since it's 12%, we can just write 12 over 100. So you can write that as 12 grams of NaCl over 100 grams of solution, right? If you take 12 divided by 100, that is 12%. So the percentage is just a ratio, and generally you just put it over 100 just to make things easier. And then we can see we have grams of solution on the top here. So we want grams of solution down on the bottom. And then 12 grams of NaCl would go up on the top. Grams of solution and grams of solution would go ahead and cancel out. And then you'd go ahead and do the math. So 235 times 12 divided by 100. You get 28.2 grams of NaCl. So there's just one example of a question that you could be asked, right? And you can tell it's all conversion unit type of questions. So just convert, convert, convert. But think about other ways that I could make this question more or less complicated. So for example, instead of giving you grams, I could give you moles. I could say, hey, what if you had, how many moles would you have? And then you'd have to go from grams to moles. At this point, going from grams to moles should be very simple to do, just using the molar mass. That's something that you really should have memorized. Another thing that I could have done, instead of giving you grams, I could have given you a volume. I could have said 235 ml, and then you had to go from grams to ml given the density. So there's all kinds of little ways to change the problem up a little bit, but it shouldn't make too big of a difference. Let's take a look at another example question. So here we're going to have 23.5 grams of methanol in 125 mLs of ethanol. And ethanol has a density of 0.789 grams per ml. What is the mass percent of the methanol? And so, of course, we know that mass percent is equal to the grams of the solute over total grams, which would be your grams of your solute, plus the grams of the solvent, right? In this case, we just have two things. So we just have two things here. So we can think about where we're going to take these numbers. It's 23.5. That's already grams of solute. So we'll plug that in both the numerator and the denominator. And then what other value do we have? We have 125 mils of ethanol, right? But this is in grams. So that's not going to get us quite there, but it's going to help to get us there. So if we have 125 milliliters of the ethanol, how do we go from milliliters to grams? We can think about what other units we have. And if you take a look at density, it's grams per ml, which tells you that it allows you to convert between grams and mLs. So ml on the bottom, because over here it's on the top. And then 0.789 grams there. Go ahead, do the math. 125 times 0.789. And you should get about 98.625 grams. With, of course, 3 sig figs. And so then you take this value right here, plug it into your grams of solvent, of course, multiply it by 100%, and you should get 19.2%. None of this should be totally new. Again, it's just unit conversion with now just a new type of unit. So chemistry is often difficult for students. One of the reasons that it's difficult is we often teach skills, not facts. We do both, but we focus a lot more on skills than a lot of other courses do. And you really want to think about what's going on there in terms of the learning process. When you're asked to memorize just some facts, right? You know, this is a cell, this is a mitochondria, this is that, this is that. There's not a whole lot of critical thinking ability. Whereas when you're asked to learn a skill, there's a lot more critical thinking involved and a lot more practice needs to be done to master that skill. So for example, if you're just memorizing facts, you could use note cards. But for skills, you really need to practice the problems, right? And these are basically all the problems we're going to see are plug and chug type of problems, plus some conversions in there. So we need to be very comfortable with both of these types of problems. And the only way that we can get comfortable is through practice and active learning.